Section 6.1, which is on polygons. So 6.1 in the book is a little bit different than what I had in my notes, so that's why I have a part 1 and part 2. So a polygon, have you guys heard that word before? Okay, so what, give me an example of a polygon. What's a name of a polygon? An example of a polygon, yeah.
Parallelogram?
A parallelogram. A what? An octagon, a rectangle, a square. What about a circle? No, why?
It has to have straight sides.
It does. It has to have straight sides, right? So a polygon has to have straight sides, and those straight sides have to be connected. So it's formed by 3 or more segments called sides. And each side intersects exactly 2 other sides, one at each endpoint. The endpoints are called, what do you guys think? What's an endpoint called? You could call it maybe a corner, but that's not quite right. A vertex, yep. Anybody know the plural?
Vertices.
Vertexes. Vertices, yeah. All right, so you can name a polygon by listing its vertices consecutively. So for instance, I could name the polygon above. I could call it A, B, C, D, E. Or I could call it like E, D, C, B, A. Or I could start with any of those vertices. So I could start with like C, B, A, E, D. Those would all be names of that polygon. I cannot do something like E, C, A, B, D. That would not work. Do you guys see why not? You're skipping around. You're like E, C, A, B, D. That doesn't work that way. You have to go in the order around. And you can go counterclockwise or clockwise. So of these pictures, do we think, which ones do we know for sure are not a polygon? D. So we think D isn't. Why is D not? You're correct. Yeah, Kusho? It doesn't have that straight side, right? So it's not straight here. So this one's no. What else? Yeah, Cam?
E.
E. Why?
Because one of the sides isn't connecting.
Yeah, it doesn't connect. Any others? F. What do you think? Why? Yeah, it crosses, right? It's kind of like there's 2 polygons there, right? So it's not a single polygon. So we couldn't have them like intersecting in, I don't know how to describe that. They can't like overlap on the other sides. So this is a no. So I'm just going to write, really it's 2 polygons. All right, but these other ones are. So this one is, so A is, B is, and C is. And polygons, yes. Do you like how I spelled yes there? It has been a long break for me as well. I've been in art history mode. Okay, so these ones are polygons, and they all have names. Okay, so like C, we would call a, see how there's 5 sides? What do you guys think we call a 5-sided hexagon? A pentagon, right? So it's a pentagon. And this one's, B is a parallelogram. We're going to learn all these names throughout this chapter. Hopefully you know a lot of them already. Okay, this one's not, it's kind of weird. There's 4 sides to it. So what do we think we call it when it has 4 sides? Quadrilateral, and it's what we would call a concave. Do you guys see why it's concave? It caves in on itself. Okay? So we're going to learn all those words. All right, so let's start with the names of polygons. 3-sided polygon. Cam.
Triangle.
Triangle. Ding, ding, ding. Yep. And you guys just said a 4-sided was a quadrilateral. I always want to have a mathematical spelling bee. Maybe for Pi Day, I'll do a mathematical spelling bee. Can you spell quadrilateral? No. 5 sides. Pentagon. Like in DC, there's the pentagon, right? It's shaped like a pentagon. 6 sides. Rhett, do you know this one? Hexagon. 7 sides is the hard one. Ah, so we have 2 answers. So some people say septagon, some people say heptagon. It is heptagon, I know. It's so confusing. And I'll tell you why it's confusing in just a second. 8 sides.
Octagon.
Octagon. 9 sides.
9-sided.
Ah, this is my favorite. Yes, you're right. Nonagon. Okay, everybody say nonagon. Isn't that so satisfying? Isn't it fun? Nonagon. It's my favorite. 10 sides. Decagon. 12 sides? Oh, this is another fun one. Dodecagon. So we add 2 to the decagon and we put do in front of it. Dodecagon. N sides. N-gon. And we use this when we don't know the name. So like an 11-sided one has a name. You can look it up if you want to. But most of the time we just call it an 11-gon. Because who wants to memorize all of the names? Like 123 sides. It's a, I don't know. Like who memorizes all this? So we would call it a 123-gon. Does this make sense? Okay, trivia question for the day. Is anybody in our wonderful trivia team? What do you call it? Academic team. That's why I'm not on trivia team. Anybody on our academic team that knows the answer to this question? Okay. Stems. So like if you take English classes, you learn like stems to words. Like by usually means 2, right? Try means 3. Okay, dec does mean 10. That's why it's 10 sides. Oct does mean 8. That's why it's 8. But on our calendar, we have October. And is it the 8th month? No, it's the 10th month. All right, and December is the 12th month, but it's really our stem for 10. Joseph, you know why? Yes, we used to have 10 months. And why do we no longer have 10 months?
Because Julius Caesar added June and July.
Oh, close, almost. She says June and July. Julius Caesar added definitely July. Yeah?
August as well.
Ah, so what's August?
Augustus.
Augustus Caesar. He thought that they were so important that they needed months named after them, and it's messed up our entire calendar since then. It no longer has 10 months, it has 12, so we are off by 2. That's why nonagon, November, is 9, right? October, and so on. That's why a lot of people want to say that this is septagon, because it kind of follows the September, October, November, but it's not. It's heptagon. Yeah.
To be fair, we used to have 360 days, then the ancient Egyptians messed that up.
Well, you know, I think the Earth's rotation, I don't know. It depends on how many hours are in a day. I don't know. Interesting question. All right, so convex polygon. So a convex polygon is a polygon in which no line that contains a side includes a point inside the polygon. This is a very confusing definition. I'm going to show you a concave one. Do we agree that that's probably concave?
Yes.
Okay, so a line that contains a side includes a point inside the polygon. So no line that contains a side. Extend the side. So if I extend the side of this polygon, is there a point on the inside? Yes, that means it's concave. But if I have a convex polygon and I extend all of the sides, do they ever go inside of the polygon? No, they stay on the outside. That would be a convex polygon. Okay. I think you guys know the difference between convex and concave. You probably learned in elementary school that concave caves in, right? You guys see how this caves in on itself here? There's like a little cave created. That's concave. So number 1, so identify the polygon and state whether it's convex or concave. So when I say identify the polygon, name it. I want you to count the sides. How many sides does it have? 1, 2, 3, 4. 4 sides. So it's a quadrilateral. Quad means 4, right? So it's a convex or concave? Convex quadrilateral. And then as you'll see in this chapter, quadrilaterals will break into many things. So we'll start to be able to say, oh, it's a parallelogram, it's a trapezoid, it's a kite, it's blah, blah, blah. This one's just a quadrilateral. It doesn't break into a separate. Okay, so how about this one? Let's count the sides. 1, 2, 3, 4, 5. 5 sides. Convex or concave? Yeah, Maya?
Concave.
Concave. So it's a concave what?
Concave.
Oh, you're stealing her glory. Concave pentagon. All right, other words that we know. You guys know these words, right? Equilateral. What does that mean to be equilateral? Equa means equal. Lateral, do you know what lateral means? Sides. Equal sides. All of the sides are the same. Equiangular means all of the angles are the same, right? Give me an example of a shape that has all angles the same and all sides the same. Yeah.
Square.
A square, perfect. Or an equilateral triangle would work, right? So when something has all the angles and all the sides the same, it is what we call a regular polygon. You'll see that word a lot to know that word, regular. So we need all the sides to be the same and all the angles to be the same. You guys can always turn your seats too. I see the back of your heads. I know this room is difficult to learn in. All right, so how about this one? Is this a regular polygon? Tell me why or why not. Cam?
No, because I don't think it's equiangular.
Right, so it's no because it's not equiangular. Because this is like 90 degrees and this is an obtuse one, right? And this was acute. Well, actually, I don't know if that one's acute. It's kind of hard to tell. Okay, what about the next one? Is that regular? No. Why? Not equilateral. The sides aren't all the same. Okay, a diagonal of a polygon. So let's say we have a polygon. A diagonal goes across the polygon to another vertex. This is a diagonal. Okay. Everybody look up here. Explain to me why this is not called a diagonal. What is it really called? Starts with an S. It's a side, right? That's a side. That's not a diagonal. So tell me, so a diagonal has to go across the diagonal to a, we always say to a non-consecutive vertex. Do you guys see how these are consecutive? They're next to each other? So they can't be next to each other, otherwise that would be a side. So we have to go across to something that's non-consecutive. Okay? Okay, there are patterns to find out how many diagonals are in an object. Okay. So if I start here, notice how I had 2 there. This one has 2 as well. But then when I get to these other ones, I've already counted this one, so I can't count it again. And then I have that one, right? There's a pattern to find that. If you guys can come up with that pattern and tell me tomorrow, I might be willing to give you a bonus point. Maybe a bonus point for the first 5 people that come up with it. So how about this one? So how many diagonals can be drawn in the polygon on the right? So I have 1, 2, 3 from that one. 4, 5, whoops. 4, 5, 6. We've already counted that one. 7, 8. Any others that we're missing? Yeah, right here, right? Whoops, I tried to do a green. It doesn't want me to do green. We'll do pink dotted. That one. So are there 9? Any others? Yeah, this one has 9. Okay, so there's a pattern to that. Don't be cheaters. Don't look it up. You can find everything on the internet. If you're getting your bonus point, it has to be legit. You have to tell me how you got it, how you figured it out. All right, so interior angles of a quadrilateral. So the sum of the measures of the interior angles of a quadrilateral is what? So what do you guys think? So a quadrilateral, the most basic one is a square. What are these angles here? How many degrees are in them? And what do they add up to be? 360, right? You guys see they're all 90. There's 4 that are 90, and they add up to be 360. Okay? That is true for every quadrilateral. Okay. I think I'm getting really close to time. It's 2 o'clock. Okay, maybe we can do one more. We'll stop there. Let's stop here and we'll do, well, actually we can do these. So if it says find the measure of angle F, G, and H, and you have something like this, do you guys remember what these markings mean from first semester? What does that mean? They're congruent. So because of that, I know if I had 55 on the first one, this one's also 55. What equation could I write to find X? Yeah, Cam?
2x plus, what I think is 105.
110.
110 is equals 180.
Yeah. Oh, close. 360.
360.
Okay, so we can do X plus 55 plus X plus 55 equals 360. So as Cam was saying, that ends up being 2x plus 110 equals 360. And we can solve it from there. I didn't give myself much room, did I? So if I subtract the 110 over, I get 2x equals 250. So x is 125. So when it says find the measure of each one, the measure of angle F, G, and H, well, G was 55. We got that right away. How about F and H? They're the 125, right? That's a pretty easy example of things that add to be 360. Do you think they're going to be that easy on my tests?
No.
No. Might have fractions. Maybe some substitution, elimination, maybe some factoring, all these things. Okay, so how about the next one? So again, we would just add up these 1, 2, 3, 4 things, and we would get 360. Does that make sense? Easy enough? All right, so let's stop there.